right, good afternoon, everybody. So happy to be here and be here with you today. My name is Donny. I am an iOS engineer, first and foremost. Have been for a bunch of years now. Been doing development for way longer than that. I would say probably about 12, 13 years, something like that. That I've been doing this professionally. And for a while now, I've also been doing this as a freelancer, consultant, doing a lot of speaking, writing, all that kinds of stuff. Basically helping people get better at doing development. So my talk for today is called Combine Into Your Existing Delegates and Callbacks. And then I realized, wait, this is a conference where we won't have many iOS developers, and we won't have a lot of people who would know exactly what everything is. So I kind of relabeled the talk a little bit to be a little bit more unspecific, to say introducing new frameworks and technologies into an existing code base. So we're still going to talk about Combine, we're still going to talk about delegates and callbacks. We're going to view it from the lens of somebody who might introduce something other than Combine into their code base. So in 2019, Apple introduced Combine. And if you know Apple, what they typically do is they'll be like, you know what, in 2019 we release iOS 13, and everything that we put in iOS 13 is going to be available on iOS 13. iOS 12, you don't get it. No new features for you, only for people who update their devices in September as soon as we release our new version. So that means anybody who had to support iOS 12 could not use Combine. And if you don't know what Combine is, it's Apple's functional reactive programming framework, and it's very similar to tools like RxSwift, RxJava, and RxJS. So it just allows you to do reactive programming. And alongside Combine, Apple released SwiftUI. And SwiftUI is a declarative programming environment, right? It's a declarative UI framework that is very similar to tools like React or maybe Flutter and that kind of things. So it's very reactive in its nature. Whenever something changes in one of Combine's streams, then the UI will update with SwiftUI. But this was all iOS 13 plus, and a lot of people had to support iOS 10, iOS 11, or iOS 12, so companies could not jump on Combine immediately. So now in 2022, companies are leaning more and more towards Combine and SwiftUI as well. And that's sort of where I come in and where they ask me, well, Donny, you wrote a book on Combine. How do we start it? How do we start using it? How do we put it in our code base? And is it risk-free? How do we do that safely? And how can we start migrating code? Because we have a huge existing code base and we can't just throw it away and do everything all at once. And then, of course, when we start talking, they're like, wait, what about async await? Because in Swift, we didn't have async await until last year. So that is a huge deal because that allows us to do asynchronous programming, and it has a lot of overlap with Combine, as we'll see throughout the talk. So what about that? And how do we integrate new technology into our code base without breaking everything and without chasing something new every few years? So before we continue, let me sort of give you a talk outline. First, we're going to explore current state of code bases a little bit, right? Because to answer the question, where should we go, we need to know where we are, because we can't just randomly run places if we have to maintain a current code base. And then we'll briefly move into understanding how things like closures, callbacks, delegates are used in the real world. So we'll look at some examples to see how these things fulfill certain roles. And then we're also going to introduce Combine into each of those different use cases to see how we can do that in a safe way without breaking all of our code in one go. And of course, we have to talk about async await. In these days, in 2022, I cannot stand here and do a presentation about Combine without also talking about async await a little bit. And of course, in the end, we're going to summarize everything we've learned, and we're going to hopefully walk away with some inspiration of migrating code bases. So let's see if we can understand today's code bases and our use of async patterns, right? Because Combine, it's doing a lot of asynchronous work, right? Sort of when it's publishing changes, when it's telling SwiftUI when views need to update. That might not always be something that happens in a synchronous fashion, as we'll just see in a moment. And also, in current code bases today that don't use Combine, right? How do we do network calls, and how do we respond to changes in state? Because in the wild also, code bases are very different, right? Some people might work in agencies or be starting a new app right now, or they might be indie developers who start new projects every couple months. And every time they start something new, these people, they will have a very different vision than they had the last time. But on the other hand, you have companies that have released apps on maybe iOS 2 when Apple opened up the SDKs, and they might have had code bases they had to maintain since then. These people don't get to choose new technologies every year. They have to think about how to migrate every single time. And these code bases adapt much slower than new code bases, right? You can't just rewrite code every time for the sake of it. You have to carefully decide, what am I going to rewrite and how am I going to do this? And that takes a lot of time. And that's also why a lot of bigger companies with existing apps are only now starting to actually integrate things like Combine and SwiftUI in their code bases. Okay, so let's look at something that you would find maybe in a code base today. A typical network call. Right? We define a function, and that function takes one argument, which is a completion handler. It's a closure that will be called when this network call that we want to make completes, and we pass that closure the result of our network call. We build a URL, we use URL session to make our network request, and note that this data task function also takes a closure, right, to inform us about completion, and then we call our completion handler. Obviously, this code is very much incomplete, right? This basically only reasons about sort of half about a success case, and then we magically have some decoded data. If I would put everything that you might want to do here, it wouldn't fit on the slide. That's simply why. Right? Normally, you would maybe want to set some headers, handle some caching, maybe do some authentication, token validation, and that kind of stuff. So this call should actually be a lot bigger in the real world. Now, if you want to execute our network call, we will have to call this load data function. And we would do that by calling the function and passing that function a completion handler that takes the result, and then we can use the result. Right, if you've written Swift before, this should look super familiar. If you haven't, this also should not look completely outrageous. And this kind of a setup, where you simply pass closures around to receive completion, is probably the most common use of closures I've ever seen. Right? Everybody has this in their code bases. And I've even seen this outside of Swift as well. And if we look at what this really is, a completion handler is a handler or a closure that is called whenever some asynchronous work is done. Right? It's finished, we want to know that it finished, and we want to know that there was a result. However, sometimes there is no result. Sometimes we just want to know this asynchronous operation was kicked off a while ago, and now it's done. And we expect this handler to be called once, and this is important to remember. Right? If you would receive a call to your completion handler multiple times, that would be weird, because if something's completed, it's completed. How can it complete twice? Now, a slightly less common use of closures that I've seen is something like this. Right? The purpose here is to observe state. And what you're looking at is a property called tracks, and whenever that changes, a closure is called, which is called onTracksChanged, and somebody can assign a value to that closure to have that be the handler for changes to this property. And while it's not very common, it is useful, and this pattern allows us to provide a handler or observer that's called whenever tracks is changed. Right? So whenever our state changes, we can be informed about it. We can't use this kind of a pattern if multiple objects want to be informed, because we can only assign one value to this property, and if we assign another value, then the old value is gone. And a setup like this that is sometimes used in production code is very, very similar to reactive programming. It's not quite the same thing, because we can't do a lot of the things that we can if we would have reactive programming. But it's a very rudimentary form that does the very bare minimum of allowing to respond to state changes. And what's important to realize is that the closure that we're using here can be called multiple times, because this state might change value a couple times. So comparing the two kinds of closures that we often see, one is a completion handler, called only once, signals completion, and it can communicate a result. On the other hand, we have change handlers. They're called anywhere between 0 and infinity times. Right? A state might never change, or it might change very often. It signals that some value or some piece of state has changed, and it can communicate this new value to us. And this is, of course, incredibly useful, because that allows us to respond to changes. And once we start migrating each of these two paths to Combine, we'll realize that they both have very different migration paths. And to determine a migration path, we need to think about what are the requirements for us when we refactor our code. right? Because refactoring is something you can't just randomly do and start somewhere and hope that you end up in a good place. So you have to think about it. And one of the things that you never want is to break your existing code. So you want to avoid breaking that as much as you can. If you end up in a state where you're going to have to refactor for 2 weeks, maybe a month, that might be a big problem. And we also want to introduce new technologies slowly. Right? We don't want to move so slow that we're basically never doing it at all, but we also don't want to rush in head first without thinking about it. We want to see how it works, see if we're doing the right thing. And in the process of this, we also don't want to duplicate too much of our code. Right? You could say, well, if I want to introduce a new technology, I'm going to copy everything I have, paste it, make some modifications. I have everything side by side. I can move slowly, and it works. But then if you want to change something, you have to change it in 2 places. Before you know it, it's going to be 3, 4, 5, 6 places. And it's going to be a big mess, so you don't want that. Okay, so before we start refactoring, I start showing you some ways to take a completion handler-based body of code and move that to combine, or the other closure and move that to combine. Let's do a quick combine speed run. So again, combine is a functional reactive programming framework, and we use pure functions to transform certain values into new values. Right? Combine works with publishers, and these publishers tell you, hey, this publisher is now telling you that there's a new value available, and it's this specific value, and then you can transform that value into something else, and you can use other operators as well. You can also use timing-based operators. Right? These, for example, allow you to say, I want to have a search field that's going to be shaped as a publisher, so it's going to be telling me when that search field's value changes, but I want the user to stop typing for about 0.3 seconds before I actually handle what they typed. Just an example of a timing-based operator. Publishers provide us with values. Right? They tell us the current state for some value that we want to observe. And we can build whole pipelines of operators, right? We're not limited to using 1 or 2. We can use many of them. So putting that together in a very small example, we might be looking at this. We need to manage the life cycle of a publisher somehow, right? Because once we start listening to changes on a publisher, we need some way to determine when we want to stop listening, right? And we can use something called an any-cancelable for that. And what you need to know about is that as soon as an any-cancelable is no longer used anywhere, it will cancel whatever it wrapped. You can make a publisher, and publishers are very similar to arrays. So Apple actually added a way to turn an array into a publisher, which is mostly useful for demos like this. We can transform the values published by the publisher by using a map, for example. We can receive the values that we have from our publisher and then mapped, and then we can get them here. And of course, we need to make sure that the pipeline we created and the subscription we created is properly managed by holding on to the cancelable until we no longer need it. Okay, so that's the very basics of combine in just a couple lines of code. Now, combine publishers emit any number between 0 and infinity values. Right? Some publishers might complete at some point, others might never complete. They can communicate a completion event, so a publisher, when it completes, will tell its subscribers, hey, I completed, I'm done, you can move on to the next thing now. They can communicate new values, so whenever state changes, you will know about it. And they can basically do what we did before with completion and change handlers, so that's great. So now that we know about this, we know that combine can in fact replace completion and change handlers, which is great. That's what we were looking to do in the first place. So again, you might remember this code right here, right? It took a completion handler to signal that something was done with the load data function. If we migrate this to combine, we end up with something like this. It's a lot less code, and it does more, actually, right? So we don't pass a completion handler to our load data function. Instead, we return a publisher object. We make our URL, and then we make a data task publisher to make the actual request to the network. And we map it so that we get data out of it, we decode it into our model type, and we, very importantly, erase this to any publisher. That's what allows us to return an any publisher object instead of something a lot more specific. And this is great, but this is very simple. We don't do token validation, we don't do caching, we don't do header setting, we don't do a lot of things. We just made the simplest network call we could. And doing this, what I did here, is also way too impactful. Even though this was a tiny bit of code, I copy-pasted my logic from the one network call to the other. So if I would do this in a real code base, and I would copy all that token logic, all that header logic, I would have a huge refactor on my hand, and I would have duplicated code, and that's not what I want. So instead, I can do this. It's about as many lines of code, and we still build on any publisher object, but instead I use combines future. And a future is an object that takes a promise, very similar to what you might know from JavaScript or another programming language. We can call our existing load data function that takes a completion handler. And once that handler is called, we can fulfill our promise and tell that future publisher to send out the value to whoever is interested. And of course, we erase this to any publisher to hide the fact that we used a future. And that's really important, because if we don't do that, we lock ourselves into that function returning a future. And of course, the end goal is to migrate everything onto Combine and eventually say, okay, nothing is using this completion handler anymore except this combine function. So let's refactor that and complete our assignment. So this is a very simple way to take completion handler or callback-based code and bring it to Combine. We can use futures for that. And what's cool is that we can slowly start integrating Combine this way, right? We can have our old API and our new API existing together. And by erasing to any publisher, we can hide the fact that we used a future, which allows us to later refactor that future out of our code base and have the same API and not have to refactor again and again. But this future can only be used for one-shot actions. The future's promise is fulfilled once, and then it's completed, right? So we only complete once. So this really only fits for the completion handler case. So what about change handlers, right? I showed you that as well in the beginning as another use case for closures, right? We looked at this code right here, actually. And this is basically the important bit here. And this function is called whenever this changes. Okay, so now that we know that, how do we use this actually in code, right? I showed you earlier how we've called the load data function with a completion handler. This would be used either in the top way, where we simply assign something to this variable, or we could pass a handler for the on-tracks change to the initializer for our track list view model. Okay, that's all great, but we can replace that with combine, and that's what we wanted to do, right? We want to introduce a new technology here. And the easiest way to do that is to literally write this. And I changed my tracks property to this line. It's now marked with @published, and that turns it into a publisher automatically. This is a really cool feature in Combine, right? Any state object or any piece of state that you apply this to, whenever it changes, receives a new value. You can subscribe to the publisher that's created, and you're listening for it. Now, this is a little bit more of a refactor than I would like to do, maybe, because I no longer have my old API in place. I can't assign to that on-tracks change property anymore. But that had a one-to-one relationship anyway, right? So this means if I do this, there's only going to be one place in my code that I have to refactor. Not that big a deal. But we can have it coexist, as you'll see in the end. Okay, so using this new way of observing state, we can do it like this. It doesn't involve too much code. We obtain a publisher for the tracks by saying viewModel.$tracks. That is how they expose the publisher for a property. And we subscribe to it, and we can use the tracks. And that's all we need to do. So that's pretty cool. And replacing change handlers with combine can be done without breaking anything, right? I'll show you how you can break absolutely nothing, because we kind of broke something just now, but we only broke one place in our code. So it has a limited impact as a breaking change. In this case, we'll often be working around the view level anyway, so that means that we are far less intense in scope than when we work in something at the core of the application, like a networking layer. And refactoring like this has a much smaller impact than refactoring a callback-based API, simply because of how it's used. Okay, so that's change handlers. And then I also promised to talk about delegates, which are pretty much an ancient pattern on iOS that was mostly introduced because Objective-C didn't have completion handlers, right? So you had to assign some object to say, hey, if something changes, you have to tell this object about it, which it's an interesting pattern. And to really figure that out, let's go ahead and quickly build a combine-based location provider, right, that we can use to obtain a user's current location in a way that is reactive. We'll use a CL location manager object and CL location manager delegate. And it will be an object that wraps this manager plus delegate. And that one object will expose two publishers, one to get a user's current location and one to get the device's current location permissions. Subscribers will receive the user's last known location and any new locations. This is what the initial solution might look like, or rather the location provider itself might look like. And as you can see, it follows the pattern you saw before, right? So even though this is going to be delegate-based, we still have some property, and we want to know when it changed, right? Because that property is going to reflect current location or the current location permissions. To actually implement the location manager delegate, we simply implement two functions, and we say if the user's authorization status changes, change that property that reflects the location permissions, and if we get a new location, make the current location the last known location for the user. Relatively simple, and if you've sort of figured out how that published property wrapper works or how we can use that, you might be thinking about a solution already. But let's set some requirements for this. We want to maintain our current API when we introduce combine into this object. The refactor should have a minimal impact because that's what we always strive for when introducing new technologies. And we might just do this. And if you're struggling to see the differences, I added the published annotation to that one property. I didn't change anything else because I can still use my old API if I really wanted to. But I do have two publishers now. One for the permissions, whenever we assign to that, we can subscribe to that change, and one for current location. We can also subscribe to that change. So building this object, when you maybe heard I was saying, let's build this, you thought maybe, oh, that's going to be very complicated. And actually, it's relatively trivial due to that published property wrapper. Because we can use that to quickly transform anything into a publisher, which is very neat. And it allows us to easily observe state, which is very important to us. In this case, at least. And if at some point I say, okay, I don't need my old closures anymore, I don't need to know when this change, my change handlers can go, I can refactor this manager into this and have the two methods simply assign current locations and location permissions. And I have a delegate that is now brought into the combined world, which is pretty cool. Using this object, it looks a little bit like this. Right? I can just say provider.$currentLocation.sync. Now I can receive current locations and any subsequent locations that the user visits. All right, cool. But you might be thinking, he's been talking for about 20 minutes now, but async await will replace combine, so why even bother with all this? And let's see if it actually can, right? Because I've been asked this, and I'm definitely not paying attention to places like Twitter where people have very big opinions on this. So let's take a look at what it looks like to actually refactor to async await. If you look at our old networking call, the combine-based one, it looked like this. Not too bad. We use it like this. Also not terrible. But I'm sure you can agree that this looks better, right? We have a function defined as load data async throws, which means that it's going to do some async work, could fail, so it might throw an error. And if everything goes well, we return some model. This reads easier than at any publisher, and it most certainly reads easier than the callback-based version we had in the beginning. And simply the whole method, it's only 4 lines. It reads like synchronous code, but it's actually async, so that's really nice. Using it's also a little bit easier than it was with the combined one. We don't have to worry about cancelables. We don't have to worry about lifecycle management. We simply want to get the data and use it. Easy enough. Now, sometimes we can't do what I just showed you. We can't just randomly call asynchronous functions because we need to be in an async context in Swift. Right? We have to be in a context that can be interrupted to wait for something. So if that's what we need, we can create a task, and it's still pretty okay, this code. It's really not bad. So yes, for the networking and completion handlers, it's pretty much a no-brainer, right? If you can choose today, do I write my networking layer in combine or async await? You're probably going to lean towards async await. And yes, you can also introduce async await in a similar way that we just introduced combine, but I'm not going to show you that today. But you can introduce that gradually if you want, which is what you should be doing. But let's talk about async await as a state observer, right? Because this is what we had before. Right, we had our cancelables, location provider, 2 publishers that we can subscribe to reactively get the user's current location or location permissions. And we can actually model this with async await as so-called streams, or rather async streams. And I'm not going to show you how to build them, because that's actually pretty complicated and involved. What's really convenient is that you can make a combine publisher into an async stream really easily. So let's go ahead and do that and see if the benefits we get are as good as they were for the network call. So what I'm doing here is I have my publisher, similar to what I had before. I turn it into a stream, and I actually transform the value a little bit too with a map. And that's not combines map, that is map on an async sequence. And it works very similar to map on arrays. Then we start iterating over the stream by saying for try await value in stream, and we get values. Now, this looks really good. All right, so let's apply that to our location provider and do this. And if you have ever used for loops, right, you see one for loop and then another one, you know that this won't work, right? Because that second for loop we had can only start when the first one completes. But that publisher that we had that's telling us about the user's location, it's going to tell us every time the location changes. So it's not finishing after giving us one location. It can take forever, the duration of our app lifecycle, for that publisher to complete. So we need to find a way to run both of those for loops concurrently. And we can do that by putting them in tasks. All right, so if we make two tasks, we create two asynchronous contexts, two scopes that can run concurrently, and now we can loop over each of these two async sequences, which is really nice, right? We create one task, two tasks, and this is perfect, but we do have a problem. Our task lifecycle is not bound to anything. So that means that if the object that uses our location provider goes out of scope, it's no longer needed, the tasks that we are using for iteration are not torn down. They will stay around. So we will continue listening to our location provider, even though we don't want it anymore. So let's say we have this object, right? If we look at this, and then we do this, right? So we make an instance of our view model. We start observing the location provider, and then we set our view model to nil. The view model should go out of scope, and everything should be torn down. Right? We don't want to observe locations anymore because this object that is interested in the locations is no longer around. But there was a bit of a problem in our code. Right? Our view won't actually be delegated, and our tasks are not canceled. That's not what we wanted, because right here, if we look at this, we strongly capture self implicitly, mind you, because I never used the word self in this code. But we do capture self, right, by accessing the location provider, which means that the task now has a strong reference to self, which means that when I set that view model to nil, there are still two objects holding on to my location provider, namely the two tasks. We don't want that, so we need to manage tasks carefully. And we should make sure that we don't accidentally capture self strongly, and we should make sure that we break out of iteration when self is deallocated. And I put this in as a bit of a joke, because there's multiple ways to do this, but we can use combine to break out of our tasks, right? So we can put an extension on tasks and say that we want to store our task in our set of any cancellables, just like where we put combine subscriptions. We'll insert our any cancelable into the set that we were given, and we'll cancel self, the task, when we need to. So we can use that to break that retained cycle, and we end up with code that looks a little bit like this. Right? Now we capture self weekly, which is great, and we store our task in cancellables. And if I look at this, what I'm doing right here, I just don't think it looks better than my combine code. It definitely was a lot easier to make mistakes here than it was in combine. Right? Because for the asynchronous iterations, we had to use tasks that implicitly capture self, so we had to make sure we didn't do that, and we have to make sure that we manage the life cycles. So this essentially is unsafe by default, which is very unswift-like, where combine is very safe by default, because if you don't hold on to your cancelable, it's deallocated immediately and the subscription is torn down. So you can't accidentally have a memory leak on your subscriptions, at least not in this same way. So to me, this just doesn't look that good, just yet. And these are only some of the obvious rough edges. I've found a couple more reasons why I feel like state observation is still a better fit with combine. So if you're wondering, why is he talking about combine? It's mostly going to be state observation for at least the next year or two. right? Maybe they iron out all the rough edges of async sequences. I don't know that. But I would say that combine is a safe enough bet, especially because if you do want to move on to async sequences, you can take your existing combine code, your existing combine publishers, and transfer it with the values property on a publisher to change it into an async stream. All right, let's summarize. More and more companies are looking to adapt combine and async await. Right, that's simply what I'm seeing as a consultant. I'm getting more and more questions about this. I'm seeing companies ask me, how do we integrate this safely? Right, both combine and async await, as well as Swift UI. And we're always looking for good ways to do this safely. Because we need to adopt new technology, whether it's combine and async await or anything else. You want to do that with minimal impact. And it really helps when we understand the patterns and features that we need to replace. That's why I spent the beginning of the talk figuring out completion handlers and change handlers and delegates. Right? If we don't understand what we're replacing, it's really hard to judge how we can do it in the best way. And finding ways for old and new technology to coexist is pretty important, right? Especially because you don't want to be stuck refactoring for 2 weeks, 4 weeks, maybe a couple months. Because in that time, you're not able to build new features, maybe. And it's always good to look ahead for alternatives and newer patterns. Right? So it makes a lot of sense that people looking at Swift UI and Combine are worried that async await will replace it. But at the same time, if you're always looking ahead at what might be coming, and you're keeping that from actually making changes to your code base, you're going to have a code base that is going to be stuck. Right? It's not evolving, that's not changing. And it's going to be harder and harder to maintain, harder and harder to write new features for. And in extreme cases, who knows, maybe in a couple years they'll replace Swift with something like how they replaced Objective-C. And if you don't migrate fast enough, you're going to struggle to find developers even able to program in the language that your app is in. Just a very extreme case, of course. So with that, I want to thank you for listening, and I'll happily take any questions that you might have.